Motherboards, Part 1. In this nugget, we'll be discussing motherboards, and we'll start off here with Part 1. This will be a multi-part series on motherboards. We'll take a look, first of all, at some of the various terms relating to motherboards so that we can all be on the same page, so to speak. We'll also take a look at the architecture of motherboards, which involves the chipset. This is going to relate to things such as the North Bridge, the South Bridge, the I/O controller hub, many other terms that we'll take a look at there. And then we'll also take a look at various form factors, and we'll describe all of them, and I'll also have a PDF file available for you to download as a description of them all. But we'll take a look a little bit more detail at the NLX and the BTX, and then in our next nuggets, as well as the context for most of the entire A+ series, we'll be addressing the ATX motherboard. I remember that when I was in college, I was designated to be the resident assistant, or RA, for our dormitory. And I went to kind of a strict and conservative college, and so it was very important at that school that everything went through proper channels and proper permission was asked to be able to do certain things. So anytime one of the students in my dorm wanted to get permission to do something, it all had to go through me, and I kind of became the authority there in that dormitory. Yes, I was drunk with power. Anyway, also, all the communication came through me as well. Anytime the administration wanted to notify all the students of a certain important, fact or something like that, well, they would depend upon me to disseminate that information somehow. And they would also depend upon me to communicate what the students needed back up to the administration. So everything seemed to go through me. And in fact, my dorm room kind of became Grand Central Station, and I had everybody coming in there at various times of the day, asking if they could do something, or apologizing for not asking for doing something, or, any different kinds of things that were going on. Well, it's kind of the same with your motherboard. Everything has to go through, the dorm room, so to speak, of the motherboard. The motherboard's kind of the resident assistant in the computing world here. Now, what I want to do here is to take a look at a few different things here as we address motherboards. This is probably the central crux of everything that we're going to be doing in computing for the A+ exam, and in real life as well. So let's just kind of describe things. First of all, it's more or less the pathway for all communication. If you have a peripheral or a keyboard or a mouse and it's sending any signals, they all go ultimately through the motherboard and then onto whatever application it is that you're trying to run. In fact, even this pen that I'm running right now, when I made this check mark right here, that eventually somehow made its way through the motherboard as well as many other things in the system. The buses are primarily used to transmit that information, and there's a number of different buses that go on inside of the computer. We'll be taking a look at some of those, but you've heard some of the terms possibly before. Some of the older ones were like an ISA bus, but we also have things like PCI Express, which is the current method that's most commonly used. And then all the connections as well go through that motherboard as well. So all the stuff that's plugged into the back of the computer. Maybe you've got a sound card plugged into some speakers. Maybe you've got an external serial ATA drive or some other kind of a USB drive attached to the back of there somewhere, or a game controller. All those things, again, eventually will connect to the motherboard. Now then, before we get too far along, I want to also talk about some various terms relating to motherboards as well. One of those is, just so that you understand, of course it's called a motherboard. It's also known as a main board, although I didn't write it in there. But very often in documentation or in any kind of online resources you see, we just usually shorten that and call it a MOBO. Okay, so that's just what you'll see there. It's the same thing. This is the main printed circuit board, or PCB. And a printed circuit board, of course, has traces of, like, millions of different traces on the PCB. They're just pathways, or the highway to and from the processor, the memory, the peripherals, all of that. And sometimes they're almost microscopic. Actually, a lot of them are microscopic, and you'd have to put it under a microscope to see some of the tiny little traces. Also, what this is going to do is, as we mentioned earlier, is it's going to connect all of the components that you have. Now, another key component that we have there is the chipsets, and we'll be addressing that as well. There are really too many chipsets to really even count right now. There's a number of different vendors and a number of different technologies involved, but there's some main functions that are common to most of the chipsets. So I'll talk to you about that. Also, with the chipsets, just so you understand what these are, they're integrated circuits, or ICs, that allow the components to communicate with each other. That's part of the motherboard function right here, where all the components will interconnect. Well, it all goes through the chipsets, which actually handle the intelligence of how to get that data from one place to the next. It allows everything to intercommunicate with one another. And probably the most common form of a chipset, at least in its basic architecture, even though if we don't always use it all the time anymore, would be something called a north-south bridge architecture. Now to get started here, let me just go ahead and zoom in a little bit so we have a little bit more room to look at stuff here. And pull this down a bit. Now, what this all starts with is the CPU, of course, because the CPU is where everything needs to communicate, as we talked about a little bit earlier. Ultimately, everything's going to have to get to and from the CPU. So when we're trying to find some kind of data, for example, maybe we're reading something out of a USB drive, or we're just accepting keyboard input, or maybe we're reading something off a hard drive or a DVD or a CD. Okay, so that data exists way down here, needs to get to the CPU, but before the CPU will determine whether it needs to retrieve that data off of those storage mediums or whatever, it will first try to see if it actually exists in a cache somewhere. Most CPUs will have a level 1 cache or an L1 cache. This is a portion of memory. It's extremely fast and expensive memory, and so as a result, there's usually not a lot of it there. Maybe, a couple of megabytes or something like that, or sometimes even a few hundred kilobytes in the older ones. So that level 1 cache there is extremely fast, and notice that if the CPU wants to access it, it doesn't have to go in some roundabout way throughout the rest of our architecture. It already has it pretty much in its own level 1 cache. Well, if it's not there, then it has to go to the level 2 cache. This is also very fast memory, and it's faster than RAM memory. It's also pretty expensive. That's why there's also only going to be, a couple of megabytes or a few megabytes of it. Although a lot of the multi-core processors now will have, for example, 2 megabytes per processor. For example, the processor I'm using to record this particular video or nugget, it's a quad-core processor. Each of the cores has its own 2 megabytes of cache. So that can kind of add up. Anyway, to get that, it has to go through the backside bus. Now, this is still extremely fast, but hey, it is slower than if it were on the level 1 cache. And then if the data that it needs is not in either one of these caches, then it will have to go to RAM. Now, I'm kind of setting this up in a kind of a pre-configured story, so to speak, of the CPU looking for data. Sometimes the CPU will already know that it's not in this location, or this location, and it already knows that it has to pull it off of the disk, for example. But if it has to search for it, it'll look for these in the order that I'm describing to you. And then if it is in RAM, then it has to pull it out of the RAM across the memory bus, through the north bridge, and across the front side bus. And a lot of times you'll see the manufacturers of motherboards advertising how fast their front side bus. They might say something like, 1,000, oops, I lost my pen there, 1,333 megahertz or something like this. So you'll see, different advertisements like this, and they'll put a big, slammer on the end of it. We're fast, so they'll do that kind of thing. And there's faster ones than that even. But in terms of computational speed, this would still be slower than getting it off of either one of these cache locations. Also, notice that when it has to pull it off of RAM across the memory bus, it goes through the north bridge, which is kind of a hub, if you will, for different interconnects, and you can see the different things that it does connect. But the problem there is now it also has to compete with the AGP video controller. Now, we're not really using AGP as much as we used to. In fact, it's kind of becoming a legacy card. Legacy in computing and in Windows terms and things means old. Okay, just like me, I'm in my 40s, so I'm kind of a legacy person. So this AGP video controller, if it's doing a high-end game and someone's really having fun playing games and looking at all kinds of snazzy graphics and stuff like that, it's probably also memory intensive. And now you have these two things right here competing with access to the north bridge, so it's going to be a lot busier, and that could affect performance. And of course, we all know that computers were invented to play high-end games, so that becomes a problem. And then if I haven't already described this acronym, AGP is Accelerated Graphics Port, and again, that's going to be likely to be replaced by PCI Express. And then RAM is Random Access Memory. Both of these things we'll talk about more later on. Now, the other thing that it has to compete with here, if you look down, is it also is going to have to now compete with the PCI bus. So you'll have PCI slots in there. There could be network cards. There could be some kind of an external controller card. There could be a SCSI card in there, which is another kind of a controller card that can connect peripherals such as external hard drives and scanners and all kinds of other things. So anyway, this is where all of our expansion would take place in this kind of a bus. Again, now it has to compete. All these things now are going to compete on the North Bridge. And so that could potentially be something of a bottleneck, although, again, this is a pretty fast bridge. The North Bridge is computationally pretty fast on its own. But then we have the South Bridge, okay? This is like where everything slow happens. I mean, look at the archaic slow things we have going on down here. There's the floppy disk drive. Wow, that thing's a real groaner. We don't even use those hardly anymore. But if we did have it, it would be connected to the South Bridge in this architecture. This is also some other things you can see if you turn your head sideways. Okay, everybody, let's do that now. Turn to the left. Yep, look sideways. Everybody else in the other cubicles wonders what you're doing right now. Anyway, these are the other kinds of devices that are connected there. IEEE 1394, which is FireWire, USB, serial parallel ports, and you see the rest. So that now is going to go all through the South Bridge. And, of course, we also have IDE, Enhanced IDE, or EIDE that we see here, which is normally where you're going to have hard drives and your CD or DVD-ROM drives connected as well. And then you'll have any ISA slots. Those are kind of, again, defunct. You won't see that on any newer motherboards. In fact, for the past several years, you won't see those anymore. So that gives you a little bit of a layout for where all of these different things are, and I would just be aware of the kind of things that are connected to this for exam purposes. Know the South Bridge, know the kinds of things that are connected here. You know, these different types of peripherals and connection items. ISA slots are over here, also connected to the South Bridge. And then I would also know that the PCI bus is in the middle here between the North and the South Bridge. And then you have RAM and AGP directly connected to the North Bridge. So those are some of the things I would know about here. And then the other kind of a controller architecture or chipset architecture that we would see would be something called MCH ICH. MCH is Memory Controller Hub, and ICH is I/O Controller Hub. Sometimes this is also called a GMCH for Graphics Memory Controller Hub because it does have the AGP video controller attached to it. But let me zoom in here because it's going to be kind of hard to see this at this magnification. So let's push in a little bit, and we will see if I can pull this down. There we go. Okay. So here we have the same idea. We have the CPU that's trying to retrieve data. Although notice that now the level 1 and level 2 cache are on the CPU, on the same CPU die right here. So it doesn't have to go external to the CPU to get that level 2 cache. It's now both right there. But again, the level 1 will be faster than the level 2, although accessing the level 2 will now be faster than it used to be in the North and South Bridge architecture. Now then again, if it can't get to the data here, then it has to go to RAM. Still have to go through the memory bus though, and we're going to have to go through the Memory Controller Hub, which is just a new way of describing the North Bridge architecture. This is going to be architecturally more efficient in a number of different ways. Then we still have this over here though, the AGP video controller, which is pretty much the same as that we used to have, and which I already described a little bit earlier in the North Bridge architecture. This is known as the processor bus or CPU bus when the CPU has to communicate with the memory controller hub. That's the pathway that it will take. And then we'll also have, let me move up a little bit here, we'll also have the hub interface, which communicates down here with what used to be the South Bridge. Now let's go ahead and take a look at what we've got down here on the South Bridge. Now, one of the key characteristics that you'll see with this, by the way, let me get into this. Key characteristics that you'll see is that we have the PCI bus has now been moved down here. Remember, the PCI bus in the North Bridge, South Bridge was right up in here between the North and South Bridge. Now it's no longer there as a potential choke point or a bus of contention, so to speak. Nothing has to go through it anymore. It's got its own direct connection to the I/O controller hub. And then we have these other things you can see, like a local area network connection, enhanced IDE, USB. These are all in one chunk of blocks over here connecting to the ICH. And then we have a super I/O here, or super input output, where these other things are connected that we had seen in the past as well. But these all used to be kind of connected all clumped together. Now they're separately connected to the ICH, which is going to be more efficient and give us a little bit faster data pathway here. We also have optionally an ISA bus. Again, these are largely defunct anymore. Don't really need those anymore. And then we have the PCI bus, which you may still see, and you'll have PCI slots, which still do sometimes appear on motherboards, but again, largely being abandoned in favor of PCI Express. And then moving on, we have another kind of an architecture here. This is a very current architecture. In fact, I think this one just came out late in 2009, maybe September. Some of the other similar ones have come out in December of 2009. And this is basically an Intel, mainly an Intel design, but many other manufacturers follow after Intel's pattern. This Intel design actually appears on an Asus brand motherboard, which is what I've got in my computer right now that I'm using to record. And I'm using an Intel i5 processor here as well. And that's what this is in the block diagram. This is the processor itself, and notice that we have the processor and then a bridge down here. What's going on with this? What happened to the North Bridge? Well, as you can see by my note here, it's integrated into the actual processor itself. We don't have a chipset for the North Bridge on the motherboard anymore, because this is going to all be taken care of right up here instead. And it has a direct interface to PCI Express graphics. You can use a single lane, or rather a single connection at 16 lanes at up to 16 gigabytes per second. Or you can use two 8-lane connections at 8 gigabytes per second each. So they're very, very cool way of working with your graphics there. By the way, what's that about? Why would you have this kind of a implementation? Well, it's because a couple of major graphics firms like ATI and NVIDIA use, in my case, NVIDIA, which is what I'm using. This allows me to use two video cards, and I can use it so that normally they're separately attached, and I can use it for two monitors, for example. So out of the back of this, I might have two. Let's just split this up so that it looks like two video cards. Out of the back, I got one monitor. And out of the back of the other one, I know that's messy, I've got another monitor. So I got a two-headed configuration with that. What I could also do, though, is between these two video cards, you can actually put a connector between them for the scalable link interface. And I don't know why they call it that, but what it effectively does is it turns it into this. And then now I can only see the output on one monitor, but it would be twice the graphics processing power only through one chip. And that's what I would do if I was ready to play a very demanding game, one that was very demanding for video, for example, or high-end graphics, or some kind of a video production or video editing or something. I might do that so it would output only to one monitor, but I would get extremely good performance out of that one monitor because it would aggregate the collective processing power from both video cards. Anyway, it's probably too much information for this little intro here because we'll talk about that more later, but you get the idea with that. And then over here on the right-hand side, the processor also directly interfaces with the memory at 10.6 gigabytes per second. That, again, is extremely fast. And we have DDR3 memory here as opposed to DDR2. We'll talk more about memory later on, but at the time of this recording and for purposes of the A+ exam, that's going to be your most up-to-date RAM, I think, in most cases there. So that's going to be pretty fast memory, and it's very effective and efficient. And then to the South Bridge. This isn't really called the South Bridge anymore. Now, it's called something else. It's called the Platform Controller Hub, but it really is the same as a South Bridge. They just changed the name of this to give it some distinction between this and older architecture. What this South Bridge or Platform Controller Hub will now do is it makes an interface to all the rest of your peripherals and the rest of the system, like USB 2.0, PCI Express, anything that's not your 16X, for example. For example, my 1X cards, it would connect to those. Let me zoom in here a little bit so we can see some of this a little better. And then we would also have things such as the network interface card, and then the BIOS is attached to this as well, high-definition audio, and serial ATA and external serial ATA as well. So that gives you a good idea for how this is working out now. Oops, I zoomed out a little too much. And so that gives you an idea there for some of the current architecture with this kind of a integrated North Bridge and PCH South Bridge. All right, now let's go ahead and take a look at some real motherboards. This one I'm not going to spend a lot of time on because it's a little bit of an older motherboard, but it does illustrate one of the things that we talked about here just a moment ago when we talked about chipsets. And that would have been that we have a North Bridge, South Bridge architecture. Starting from the top, here's the processor, and it has a heat sink on top of it. That's why we can't actually see the processor itself. And underneath this, is on top of it, that is, there's a fan and a heat sink, which is this finned device right here. Let me zoom in a little bit more so we can see this. And that's what's going to keep the processor cool. As we go on through the architecture, though, we have two bridges, remember? There's the north bridge right here, and it's got a heat sink on top of it because there's a lot of activity on that north bridge. And generally speaking, the more activity, the more electrical current is going through something, and as a result also the hotter it gets. So that's why it's got its own specialized heat sink here. These are usually made of aluminum or copper. This one's going to be aluminum, and this one over here is also aluminum. And then here we have the south bridge. Doesn't really have a heat sink on it, but that circuit right there would be the south bridge, which does all of the other functions such as communicate with the floppy drive, the IDE connectors, and the other things that we saw in the block diagram we looked at earlier. All right, now before we move on, I'm going to show you here in just a little while an actual motherboard that I'm using and some of the connectors and things that we can use so we can get better oriented with it. But one of the things you will need to know about for the A+ exam objectives has to do with the various form factors. So we'll take a look at these. First of all, the most commonly used one is going to be ATX. You're still going to see that probably for a long time to come. The form factor of this is going to be 12 inches wide by 9.6 inches deep. So it's a 12 by 9.6. The expansion slots that it can accept are up to 7 expansion slots, and it's normally going to be used for a full tower connection. So in fact, this is going to be an ATX motherboard right here, and as I was mentioning earlier, it's going to be 12 inches, 12 inches wide right here, and 9.6 inches deep, okay, this direction. So that's the dimensions of this, and like I said, it can accept up to 7 connectors. And in fact, in this case, we have 1, 2, 3, 4, I guess we have 7 right there. Then we also have a few other form factors, though, that you should be aware of. One of those would be Mini ATX. We don't really see a lot of that anymore as well, but they are still out there, and they will give you a smaller form factor so that you can also use a smaller case, be more space saving, and so forth. It's going to have a width of 11.2 by 8.2, and you can also get 7 expansion slots out of those, but you can also go up to a full tower with those as well. There's also Micro ATX. Again, this one's going to be 9.6 by 9.6, so a square motherboard, 4 expansion slots, more for a mini tower. Again, now you're starting to save more space than you would have even with a mini ATX. And if you want to get even smaller, you can do that. We get smaller and smaller pretty much as we go here. We get a Flex ATX, 9 by 7.5 with 4 expansion slots, and that's going to be also usable for a mini tower. So in a lot of organizations like corporations where they do bulk buying and they have gigantic cubicle farms and stuff like that, and they need to really save space, you're more likely to see something like a Micro ATX or a Flex ATX in order to save space in each one of those cubicles. Also, we have the NLX. I'm going to skip down here to the NLX, and I'll talk about BTX here in a moment. NLX is going to be between 8 and 9 inches. Okay, there's a little flexibility with this design. And the depth can be anywhere between 10 and 13.6 inches. And you can have expansion slots of about 5 to 7 expansion slots in general. This is also going to be potentially for a small case. But the reason why you have a variability in the expansion slots is because this type uses risers. So you'll have a motherboard and you'll have risers with this type. And I have a website here called formfactors.org, and you can see here that they have a diagram of the NLX specification. What happens with this is we have a riser card here, and in this case, the motherboard itself plugs into the riser card. So this is the motherboard with all the little stuff sticking out of it, and here's the ports along the back of it, for example. And it plugs into an expansion board. The expansion board is then connected to the case. So we have a very small, thin, smaller than a briefcase, usually, sized case that we have with this. And the motherboard itself plugs into this slot here for the riser card. Now, why would that be? This makes maintenance very simple, so that instead of when we have to remove the motherboard, for example, from a full ATX size form factor, wow, you got to disconnect everything practically and lift it out of there. It's very cumbersome, very easy to accidentally bash something or disconnect something that shouldn't have been disconnected, or pull on cables that haven't been fully disconnected yet and damaging something. Here, when you want to remove the motherboard, all you have to do is pull it out. And all the stuff's still connected to it. In fact, here's where the CPU would go. It's still connected. Here's where the memory goes. It's still connected. But you could probably take this whole thing out in like 30 seconds. And that's also why I was saying the expansion slots are going to be riser dependent, because some manufacturers might have a wider riser card here, which has more slots on it. Some might have fewer, so you don't really know how many there are going to be until you see the manufacturer. This website, again, as I mentioned, is formfactors.org, and they have all the major form factors on this website if you want to learn any more about some of these different ones. And before I forget, this PDF, as well as many other documents that I'll make available for you, are going to be found at www.nuggetlab.com, and you can download a zip file which has, this and many other documents in it. Now, another form factor you're going to see every now and then would be the BTX form factor, which we're looking at right now. I'm going to go ahead and address this and cover it now and get it out of the way, because we don't really deal with it very much in practicality. It was initially designed to address heat problems that occurred with the ATX, but there have also been subsequent improvements in cooling for ATX form factors and cases, so it's a little bit mitigated the need for BTX. Nevertheless, let's address this in comparison to an ATX. First of all, this is going to be kind of easy to spot on inspection. Why? Because when you first open up a customer's case and look inside of it, with a BTX motherboard, you open up the right side of the case as you're facing the front of the computer, assuming it's a tower. If it's an ATX motherboard, then you would open up the left side of the case. So the case has to be designed for either ATX or BTX, respectively. Now, another difference with BTX is that you'll see the expansion slots here, again, as you're facing the front of it here, are on the right side of the motherboard. On an ATX motherboard, they're on the left side over here instead. Also, with the expansion slots, they're also on the left. On an ATX, they would be over here instead. So it's all flipped around in that respect. The memory slots that we see right here are going to be parallel to the expansion slots on a BTX. On an ATX, they would be up in this section somewhere, and they would be the exact opposite orientation. They'd be going like this direction instead. Okay, so another difference that you see there. Drive connectors are up here instead of over here. Okay, so another difference that we'll see. And then probably the key difference that you'll see is the processor as well. Notice that the processor is over here, and normally on an ATX it'd be over in this section somewhere. And notice that it is kind of put in a diamond shape. It's not parallel to the edge of the motherboard. It's at an angle. And that's another distinctive of a BTX form factor, is that the processor is at an angle there. And we also have additional serial ATA connectors in this case over here, as well as, I don't know if you can see it there, but there's also an IDE connector over here. So everything's kind of just in what seems like the wrong place when you're working with BTX. And then to look at this just briefly another way, I've got here a picture of two of the motherboards. This one would be my ATX. This one would be my BTX. And you can see all the differences. Here's where the memory is going this direction. On the BTX, here's where it's going. Here's the processor, which I said earlier is at a 45-degree angle to the edge of the motherboard. Here, the processor is in a different location, and it's parallel to the edges of the motherboard. Now, here's my expansion slots on ATX. Here's my expansion slots on BTX. And those are some of the key differences that you'll see. Should be able to spot this pretty easily just on site. In this nugget, we discussed motherboards, and this was part 1. We started off by taking a look at a few of the different terms for motherboards and the various things relating to them. Then we also took a look at the architecture of the motherboards, and we looked at things such as the North Bridge, South Bridge, the memory controller hub, the I/O controller hub, and then we finally also looked at the fact that the North Bridge has kind of been integrated into the Intel processors in current architectures. And then we still have something that equates to the South Bridge, but it's actually called now the Platform Controller Hub, or PCH. So we took a look at those chipset items. Then we took a look at the form factor factors. Remember, there's ATX, micro ATX, NLX, several different other ones. I had a PDF file that you can download to take a second look at those and to get more detail with those. You can go to formfactors.org. And then in our next nugget, we'll address more detail the ATX form factor as well as how to work with the motherboard. Well, I hope this has been informative for you, and I'd like to thank you for viewing.